Hi guys, welcome back to my channel. So in this video we are finding the partial derivative using the chain rule, and here are the functions given: z equals to, x equals to, and y equals to. And we are asked to find the derivative of z with respect to u and derivative of z with respect to v. So our first step is to draw a tree diagram. This is very important because without the tree diagram it's going to be really hard to find it. So let's just find it. So the first step in the tree diagram is that you look at the first function. So first function here you have z, so you write it at the top, and then you see z is a function of what variable? Z is the function of x and y variables, right? So z is the function of x and z is the function of y. And then you go to x, and here you see x is a function of two variables u and v. Okay, so you write it over here. So x is a function of u and x is also a function of v. And then you go to y. So y is a function of two variables x, y as well, and then it's and it has u and v. So y has u and v as well. So let me explain again. So first, since we are finding derivative of z with respect to u, so first you write z, and then you see z is the function of what variables? It's a function of x and y. Then you make a branch from the z, and then you write x and y, and then you check for x. X is a function of u and v, so you write u and v, and then y is a function of u and v, so then y you write u and v. So I hope that's clear. If it's not, let me know in the comments and I will try to explain you. Okay, so now once we have our tree diagram, our next step is to find the derivative of z with respect to u. And to do that, you see it's derivative of z with respect to u. So you have to look into this diagram. Where do you find z and u? And at the end you find u. Okay, so here, if you see here, this is z and x. So this is z with respect to x. So here, if you go all the way to the down, then you get z with respect to u. So you have to go all the way down over here. And then it's not only this one, it's this one as well. You see, if you go this way, then you can find this as well. So first way is to go like this, and the second way is also to go like this, right? So derivative of z with respect to u and derivative of z with respect to u 2 times. Okay, and to do that, so I'm gonna write it over here. Okay, so derivative of z with respect to u is going to be, so first we write the relationship between this, so derivative of z with respect to x, here this relationship, and then this relationship, it's derivative of x with respect to u, and then you can write it over here, derivative of z with respect to y. So at the top you write the first function, and then at the bottom you write the second one. Okay, so just like that, derivative of y with respect to v and derivative of y with respect to u, and here it's derivative of x with respect to v. So now we can write it. So this relationship is derivative of z with respect to x. So this is derivative of z with respect to x. And now when you are within the same branch and you want to go to the bottom, you have to multiply this. Okay, so you're going to multiply these two. So times derivative of u with respect to, oops, that was x. So derivative of x with respect to u, and then you have to add in. So every time you go to the other branch, this was within the same branch, right? Now you're moving to the other branch, and for that you have to, so now we are writing about this branch. Okay, so for this you have to add in, so that's why I added. And then now first we write this one, and then we're going to multiply this, right? So now I'm gonna have to write derivative of z with respect to y times the derivative of y with respect to u. Okay, so we have our formula to find the derivative of z with respect to u. Now we're going to find each component and then plug in all of them into this formula and find our derivative of z with respect to u. So it is as simple as it is. So let's move on. Okay, so then the first step is to find this. Okay, so derivative of z with respect to x. So then, which means we're differentiating this function z with respect to x. and then y is a constant, right? Okay, so this is 4 and then y is a constant, so it's simply 4. Okay, now we are finding derivative of x with respect to u, this thing. Okay, so which means we're looking at the function x and differentiating this with respect to u. Okay, so differentiating u only, and then v is a constant, so this goes to 0. Now we are finding this derivative of z with respect to y. Okay, so derivative of z with respect to y. So this time we are differentiating y only, okay? And x is a constant, goes to 0. Okay, now we are differentiating derivative of y with respect to u. So this function, but with respect to u. I'm going to write it at the bottom because I don't think I have enough space. Okay, so derivative of u with respect to y with respect to u. So here I'm differentiating u only, so this is a chain rule, so you do just like that. If you find the derivative of this, right, so it's going to be 3x squared, right? So you bring the 3 down and subtract 1 from it, so it's just like the same thing at first for the chain rule. Okay, so bring the 2 down, and then you leave this the inside function as it is and subtract 1 from the 2. So that's going to be 1, you write it or not, it doesn't matter. And then the next step is to multiply by the partial derivative of the inside function. So this the inside function in here is this thing, 2u minus v. So you're going to multiply by this inside function. And it's a partial derivative, so you're differentiating u only. Okay, so u and v is a constant, so this leads to 4 times 2u minus v, and then if you multiply this all together, this becomes 8u minus 4v. Okay, so this is it for derivative of u with respect to y with respect to u. So now we have everything needed. So now our next step is just to plug everything into the formula. Okay, so let me circle this so that it's easier for us to spot. Okay, so first thing is this. So to find the derivative of z with respect to u, this is what we were looking for. Now we have this component, this is 4, and then this one, x with respect to u, we have this over here, just calculate it, and then plus z with respect to y, where is it? It's here, negative 10y, and then times y with respect to u. Y with respect to u, it's over here, and now it's multiplying everything all together, which is going to give, so 4 times 4, that's 16 u to the power of 3, and then negative 80 u y, and then negative, that's a positive, plus 40 y v, and that is the answer for derivative of u with respect to v. Okay, so I'm just going to do this. Okay, so, and this is the answer. So now let's move on to the second part. So the second part in here is to find the derivative of z with respect to v. Okay, and for that we'll have to use our tree diagram again. So this time we are finding the derivative of z with respect to v. Okay, so in the diagram we have to go like this to find v the first time, but there's also v in here, so then we have to go second time like this. Okay, so first time we do like this and second time like this, so we're going to multiply these two and add this two, because every time we go to the other branch we have to add it. Okay, so let me write the formula to this using our tree diagram over here. Okay, make this a little smaller so I have enough space. Okay, so I'm going to write it over here. Okay, you can just move it over here. Now, derivative of z with respect to v is going to be this times this, like I said before. So derivative of z with respect to x times derivative of x with respect to v plus derivative of z with respect to y times derivative of y with respect to v. Okay, now once we have our formula, now we are going to find each component with its derivative of z with respect to x. Okay, So before finding each component, let's look if we already calculated or not. So derivative of z with respect to x. Oh, we already have it over here. We already did calculated in the previous question, so we are just going to write it over here. Now derivative of x with respect to v. Do we already have it? No, we don't. We found with respect to u, but not with respect to v. So let's find it over here. Derivative of x with respect to v this time. So v this time, so we are differentiating v only. So this u is a constant, it goes to 0, and then bring the 3 down, so that's 24v squared. Okay, 24v squared. So I can write it over here now. Okay, so oh wait, that's a negative, so it has to be negative 24. Sorry about that. Okay, now plus derivative of z with respect to y. Do we already have it? Z with respect to y. Yeah, we do. It's negative 10. Negative 10y, and then times y with respect to v. So last time we calculated y with respect to u. So this time we're calculating y with respect to v. Okay, y with respect to v. So where's y? Y is this one, right? Okay, so here we have this, and we're differentiating v only. So again, bring the 2 down, leave the inner function as it is, subtract 1 from it, the 1 from the 2. Okay, and then multiply by the partial derivative of the inside function, and here we're differentiating v only, so u is a constant, goes to 0, so derivative of negative v, it's negative 1. So now write it all together, so that's going to be negative 2 times 2u minus v, and then negative 2u plus 2v. Oh, sorry, negative 4u. What am I doing? Negative 4u plus 2v. Okay, so this is the answer for derivative of y with respect to v. Okay, so we can write it over here. So negative 4u plus 2v. So if you if you factor all this out, if you simplify this, so this should give you negative 96v squared plus 40 uy minus 20 vy, and this is the answer to derivative of z with respect to v. And that was it for today's video. I hope you found it helpful. If you have any questions, let me know in the comments, and please subscribe and share this video with your friends, and thanks for watching. Bye.